Hello and welcome to MyScience Tutorials. In today's video, we are going to be looking at the concept of logic and mathematical processes. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So we are looking at the concept of logic and mathematical processes. Before we begin, let's have a look at what is called a statement or what a statement is. A statement is a declarative sentence, the word declarative sentence, that is either true or false but not both. So whenever we have a statement can either be true or false but not both. So a statement cannot be true and then false at the same time. It can only be one of the above, that is either true or false at a time. Now, every statement has a truth value, namely true. So a statement can either be true, which is denoted by T, or false, which is denoted by F. So that is the truth value of a statement. So it means a statement at a particular point in time can either be true, which we denote by capital T, or false, which we denote by what? Capital F. The possible truth values of a statement are often given in a table called the truth table. Now, we will be looking at what truth table is in the next example. But before we go there, let's look at how we can identify statements if we are given examples of sentences. Alright, so example number 1. Which of the following are statements? And for those that are, indicate their truth value. So A, root 2 is an integer. Now, is this a statement or not? Yes, root 2 is an integer because the answer to this question is either true or false. So root 2 we know is an integer. So in this case, it is a statement. And is this statement true or false? It is true because root 2 is an integer. Now B, why should I study mathematics? Now this is a question. The answer to this question can never be what? True or false. So if you are being asked why should I study mathematics, then you would have to give an answer to this question by probably stating the reason why you don't want to study mathematics. Maybe you are so scared of mathematics, or maybe you think it's difficult, meanwhile it is not, or any other answer you have for the reason why you think you should not study mathematics. So this is not a statement. Now let's look at C. Monkeys can fly. Is this a statement? Yes, this is a statement because monkeys can fly can either be what? True or false. So first of all, we have it as a statement. Now, is it true that monkeys can fly? Whoever says monkeys can fly, well, that person is deceiving us. Science has not taught us that monkeys can fly. So this statement is a false statement. D, please keep quiet. Now this is a command, or you are being told to keep quiet. You cannot say the answer to this question is true or false. So this is not a statement. Now E, John is a boy. Is John a boy? Yes. So this statement, or this final example, John is a boy, is a statement. And is it true or false that John is a boy? It is true. So it means it is a statement and it is true. So far, out of the 5 examples that we have, we saw that the root 2 is an integer, is a statement, and it is a true statement. We also saw that monkeys can fly is a statement, but a false statement. We also see that John is a boy is a statement, and it is a true statement. We notice that why should I study mathematics, which is a question, is not a statement because we cannot say the answer to this question is either true or false. Okay, we also saw that keep quiet is not a statement. So let's continue. So we want to look at the negation of a statement, or how we negate a statement. Now, given that a statement P, or we have a statement P, the negation of a statement P is what? Not P, and it is denoted by the symbol, this curve sign, and then a P. So what we mean by this is, when we have a statement P, if we negate the statement, we add not to that statement, and it becomes the negation of the statement, or the original statement. Sorry. So let's have a look at this. Let's look at the statement P, its truth value, and then the negation of that truth value. Now, Amma is a boy is our first statement. Now we know that Amma is a boy can never be a true statement, because Amma is a girl. So the truth value of the statement P that we have over here is false, as we can see over here. But once we negate this statement, a truth statement or a true statement becomes false once it is negated, and then a false statement becomes true if it is negated. In this case, we have a false statement, so once we negate it, it becomes a true statement. Kofi is a dog. Is Kofi a dog? No. So it means the true value of this statement is false. But once we negate the false statement, it becomes a true statement, or a true statement. So it means the negation of P for this example is telling us that Kofi is a dog, meanwhile Kofi is not a dog. Now, Johnson is a boy. Is Johnson a boy? Yes, Johnson is a boy. So this is a true statement. But the negation of this statement becomes what? A false statement. Now, let's consider the statement below. P is the statement that we have, and it states the integer 3 is an odd number. Now, this is a statement, and it is a true statement because the integer 3 is an odd number. But what if we negate this statement? How do we write the negation of the statement P? That is the negation of P. How do we write these statements? Now, there are several ways of writing the negation of a statement. I have listed here some few examples. So the first way you can say the negation of the statement P is, it is not the case that the integer 3 is odd. Or you can say the integer 3 is not odd. Or you can say the integer 3 is even. All these statements mean the same thing, and they all contradict what the original statement P is saying. And because they do, we say they are the negation of the original statement P. Let's continue. Now we want to look at logical connectives. The first one we want to look at is conjunction. So what is conjunction? Now let's have a look at this statement. Given that two statements P and Q, the conjunction of these two statements is the statement P and Q. So it means the conjunction of two statements can be written as P and Q, and it is denoted by the symbol or the phrase P and Q. So it means the symbol inverted V, or this that we have here, is what? The conjunction symbol, and it means what? And A and D. So it means either A and B or B and C. So it is connecting two variables or statements together. So it means and. Let's have a look at an example. Example number 1. We have P, that is the original statement or the first statement. The integer 3 is odd. Then Q, 7 is greater than 5. Now these are our two statements. Now if we are being asked to write the conjunction between these two statements, that is P and Q, how do we write this? So our P and Q is just combining these two statements to form a new statement. That is, the integer 3 is odd, which is this statement that we have over here, or the statement P, and then we use the conjunction connective, that is the and. Okay, so let me erase that so that we can see what we are doing. All right, so I said the integer 3 is odd is the statement, or the first statement P, and then the second statement is what? 7 is greater than 5. So this is Q. So do we see that the only thing connecting the statement P and Q is the connective in the middle over here, and that and is what we are calling the conjunction. So the statement P and Q is the integer 3 is odd and 7 is greater than 5. Now let's look at the remarks of this conjunction. The truth table for P and Q is described below. Now when we have a statement P and Q, the truth values of this statement are, now P can be true, Q can be true, P can be true, and then Q can be false. P can be false, then Q can be true, and then P can be true, and then Q can be false. Sorry, this is false, false. Okay, so when we want to write the truth table for two statements, we write true, true for the first statement, true, true, false, false, and then the second statement we write what? True, false, just to match it. Now the conjunction between these two statements is what we are having over here. So for a true statement, if P is true and then Q is true, the conjunction between these two statements is also true. So it means this is true, this is true. So true and true is true. Now for the conjunction, or for the connective conjunction, the two statements has to be true for the conjunction to be true. I repeat, for conjunction, the two statement has to be true for the conjunction between the two statements to be true, or the truth table for the conjunction to be true. Once one of them is false or both are false, the statement is false. So if P is a true statement and then Q is false, you cannot say true and false are the same. They are never the same. So if we have true statement and then a false statement, the conjunction between these two statements gives a false answer. So if we have false and true, because one of them is false and we are using the connective conjunction, it is a false statement. And then once we have false, false, we have a false statement. So let's note the conjunction for, or the truth table for the conjunction. So for the conjunction P and Q, the first statement is true, that is if both are true, and then the rest are false. So let's note this very well. The only way a statement can be true in a conjunction is if the two statements are both true. Let's go ahead. We want to look at disjunction. Now disjunction is just the opposite of conjunction. So given that two statements P and Q, the disjunction between these two statements is the statement P or Q, and it is denoted by the statement P inverted V and Q. So we say, or we call this P or Q. Let's have a look at the example that we used earlier on. The integer 3 is odd as a P statement, and then the Q statement 7 is greater than 5. So the disjunction between these two statements is just combining the two without any connective. So we can say the integer 3 is odd, comma 7 is greater than 5. So this is the disjunction between these two statements. Now let's look at the remark. Now let's look at the truth table for the disjunction P or Q. Now for disjunction, either both statements can be true to make the truth table true, or one of the statements has to be true. So whether both are true or one is true, the disjunction between the two statements is true. But once both are false, the truth table is false. So if P is true and then Q is true, we have a true statement. If P is true and then Q is false, because we are using disjunction, that is true and then the statement or false, once one of them is true, the final truth table, we have what's true as our answer. We have P to be false over here and then Q to be true. Because Q is true, it makes this also true. But once P and then Q are both false, our truth table is false. So for disjunction, the only way we have a false statement in the truth table is when both parties or both statements are false. So it means when both the truth values of the two statements are true, we have a true statement. When one of them is true, we have true statements. And then when both are false, we have a false statement. Let's continue. Implication as the next connective. Now, given that two statements P and Q, the implication of these two statements is the statement if P, then Q. I take it again. The implication of these two statements is the statement if P, then Q. And it is denoted with this. So we have P implies Q. Now, P is called the hypothesis and then Q is called the conclusion. Now, let's have a look at something. This statement P implies Q can be said in many ways. We can say this to be what? If P, then Q. We can also say P implies Q as this same statement. We can say Q if P. It still means implication. We can say P only if Q. It also means implication. Now we can say P is sufficient for Q, or Q is necessary for P. This statement or all of these statements are just referring to the statement or the implication between the statements P and Q. Now let's look at the truth table of these statements. So if we have P and Q and then we are having implication between them, let's look at what the truth values of the truth table are. Now when P is Q, it implies Q is also true. So true is true. We have true over here. But now if our hypothesis is true but then our conclusion is false, it means we are having what? A false statement. Okay, so if the hypothesis, which is the P, is true but then the conclusion does not tally with the hypothesis, then we are having a false statement. Now if the hypothesis is false and then the conclusion is true, we have a true statement. That is, false implies true. Okay, and we have a true statement. This is the truth table for P implies Q. Now if we have both to be false, P implies Q, false implies false, that is a true statement. So for implication, the only way an implication will be false, or the truth table for an implication will be false, is when the statement or the first statement called the hypothesis is true but the conclusion is false. That is the only time we get a false statement. Aside that, then we have true statements all along. Let's continue. Let's have a look at an example of everything that we've done so far. Okay, so example number 1. Suppose your teacher makes the following promises, and the promise is if you meet the assignment deadline, then you will get a bonus. Under what circumstance are you justified to say that your teacher spoke falsely? Alright, let's go and dive in. So first of all, let's break down this example that we have. So solution. Alright, so we have the teacher saying if you meet the assignment deadline. Now this is one statement. If you meet the assignment deadline, this is a statement. Then you will get a bonus is also another statement. So let P be the first statement or the hypothesis. That is, if you meet the assignment deadline, and then Q to be the second statement, that is, then you will get a bonus. All right, now we have our hypothesis, this to be our hypothesis, and this is our conclusion. Now, because we know if is starting, we know this is an implication, so it implies that P, if and only if Q, or P implies Q. So from the look at the question, we know this is an implication. So they say, under what circumstance are you justified to say your teacher spoke falsely? So it means we are trying to say P implies Q. That is, P is true if and only if Q is also true. So let's write the implication table for the two statements P and Q. So let's draw our table, our truth table. Okay, so we have the statement P, we have the statement Q, then we have P implies Q. Okay, so when filling the statements P, we have true, true, then false, false. For Q, we tend to balance it with this, so we write true, false, true, false. Now, I said earlier on, the only way in an implication that you have the truth table for implication false is when you have the hypothesis to be true and then the conclusion to be false. So true implies true, that is a true statement. True and false, we are dealing with implication. True cannot imply false, so we are saying this is a false statement. False implies true, this is a true statement. And then false implies false is also a true statement. So from the truth table, the only way the teacher who spoke falsely is when you meet the assignment deadline, but then he decided not to give you the bonus. Okay, because from the truth table, this is the only way the teacher will refuse, or the teacher will speak falsely. So let's answer the question now. Under what circumstance are you justified to say the teacher spoke falsely? So under the circumstance, this is the circumstance that you can say the teacher spoke falsely. That is, if P is true. So if P is true, we maintain it. That is, if you meet, or you met, if you met the assignment deadline, that is, you are able to submit the assignment before the deadline. If you met the assignment deadline, but you did not get a bonus or the bonus. So the only way you can say your teacher spoke falsely is if you meet the assignment deadline, or you met the assignment deadline, but your teacher decides not to give you a bonus. That will be a cheat on you because you did well to submit before the deadline. Hello and welcome to my science tutorials. In today's video, we are going to look at how to write the converse, inverse, and contrapositive of a statement. That is the part 2 of the logic tutorial. If you are yet to watch the part 1, I strongly suggest you do so, because this is a continuation of part 1 of the logic tutorial. Now let's consider the following statements. So if we have a statement P over here, and then this statement implies the statement Q, so we have a statement P implies Q. Okay, then for us to say a statement is a converse, we can only say a statement is a converse of the original statement. That is, the converse of the original statement is when we interchange the position of the two statements. That is, we now have what? Q implying P, as we have over here. So the statement Q implies P is the converse of the implication P implies Q. Okay, now the inverse of the statement P implies Q, okay, will be the negation of the original statements, that is inverted. Sorry, the negation of just the original statement will be the inverse of the implication P implies Q. So the inverse of an implication is what? Negation of P implies negation of Q. That is the inverse of the original statements. Now the contrapositive is what? The negation of the inverse of the original statement. That is the inverse of the converse. Or we have negation of Q implies negation of P. So the statement negation of Q implies negation of P is called the contrapositive of the implication P implies Q. Like I said in the beginning of this video, if you've not watched part 1, you would not understand what implication means. So I strongly suggest you go back and see our part 1. So let's go ahead and write some few examples of converse, inverse, and contrapositive. Example number 1. Write the converse, inverse, and contrapositive of the statement if you met the assignment deadline, then you will get a bonus. Okay, so let's look at the solution for this. Now, if you meet the assignment deadline, then you will get a bonus. This is a big statement and it can be divided into two statements. So we have the first statement, let's denote it with P, and that will be if you meet the assignment deadline. So if you meet the assignment deadline, okay, then the second statement Q will be what? Then you will get a bonus. Okay, so now that we have these two statements, let's write the converse of these statements. So the converse. Now the converse of this statement is what? Q implies P. So Q implies P can be written as what? We now bring Q first, okay, then we just put comma, then we add P. So it means the implication Q, or the converse of this statement Q implies P, is written as this: if you get a bonus, then you have met the assignment deadline. I take it again. The converse of the original statement P and Q that we have is if you get a bonus, then you have met the assignment deadline. Let me write that down. If you get a bonus, then you have met the assignment deadline. Okay, so we can see that if you get a bonus is from the Q statement that we have over here. Okay, we can see get a bonus, so we just added if you get a bonus to be the statement Q, then we brought comma, then you have met the assignment deadline. That is the converse of the original statement P and Q that we have. Now let's go ahead and write the inverse. Okay, now the inverse of this will be what? Negation of P implies negation of Q. So the inverse of the original statement will be negation of P implies negation of Q. and that can be, or that statement will be, if you did not meet the assignment deadline, then you will not get a bonus. Remember, inverse, we are just adding not to the original statements. So the inverse of this statement is, if you did not meet the assignment deadline, if you did not meet the assignment deadline, then you will not get a bonus. Then you will not get a bonus. So do you see that we have the original statement, if you meet the assignment deadline, but we added not. The not is what the negation over here is referring to. So if you did not meet the assignment deadline, then you will not get the bonus. The not over here, it is the not over here that is negating the second statement Q. All right, let's write the contrapositive. Now the contrapositive is the negation of the inverse, of the converse. So we have what? Negation of what? Q implies negation of P. Okay, so the contrapositive will be, if you do not get a bonus, then you will not have met the assignment deadline. So we are negating Q first, and then we are implying it to what? P. So the contrapositive of this is what? If you do not get a bonus, then you will not have met the assignment deadline. So let me try and squeeze that here. If you do not get a bonus, that is on condition that you didn't get a bonus, then it implies then you will not have met the assignment deadline. So this is how we write the converse, inverse, and contrapositive of a statement. Let's look at another example. Example number 2. Write a converse, inverse, and contrapositive of the statement, you will eat once you help with the chores. So let's write our solution. So we have two statements, P and Q. The P is what? You will eat. That is the first statement. So we have here, you will eat. That is nice. But the condition for you to eat is what? Once you help with the chores. Okay, so once you help with the chores. So let's go ahead and write a converse. So we know that the converse of this statement will be what? Q implies P. That is the converse of this statement. So that will be what? Once you help with chores, you will eat. So the converse of this original statement is what? Once you help with the chores, you will eat. Did you notice we brought the Q first before the P? That is what converse is. Now, the inverse. For the inverse, we know we are bringing what? Negation of P implies negation of Q. That is the inverse of the original statement. And then it will say, you will not eat if you do not help with the house chores. So the inverse is what? You will not eat. The not over here is what the negation is for. You will not eat if you do not help with the house chores, with the house or with the chores, sorry. So this is the inverse of the original statement. Now the contrapositive of this statement is the negation of the converse, which is what? Negation of Q implies negation of P, and that will be, once you did not help with the chores, you will not eat. That is, we are bringing the Q first, the negation of it before the negation of what? P. So that will be, once you did not help with the chores, you will not eat. You will not eat. So this is how we write the converse, inverse, and contrapositive of a statement. Hello and welcome to MyScience Tutorials. In today's video, we are going to be looking at compound statements, biconditional, and contradiction. So we want to look at what compound statements are. Now, compound statements are statements using two or more logic operations. Now, in the previous tutorials, we look at what the logic operations are. We have the conjunction, which is the AND operation. We have the disjunction, which is the OR operation, and then we have the implication, which is another operational science we look at. Now, creating the truth table is a systematic way of determining when a compound statement is true and when it is false. Let's look at an example to further understand what we mean by compound statement. Now, example number 1. Construct the truth table for the following. Now, we can see that in this compound statement A, we have the implication sign, which is one of the logic operations. We have the AND operation, which is the conjunction operation, and then we have another implication. So we can see we have three logic operations over here. We have the implications, two of them, and then we have the conjunction operation also here. So let's look at the truth table for example A. All right, so we have two statements. We have P and Q, so we write our P and then our Q here. So we have here P implies Q, so we need to write that two down. P implies Q. We also have what? Q implies P, which is the converse of this. So Q implies P. Now we have the entire condition, which is what? P implies Q and Q implies P. Okay, so let's go ahead and see the truth table for this. Now, for the statement B, we have true, true, false, false. For Q, we have true, false, true, false. Now we can now go ahead and use these two truth values to find the other operations that we have, or logic operations. Now, P implies Q. Let's look at that. Now, P implies Q, as I said in the previous tutorial, can only be false if the starting condition is true and then the ending is false. So it means for the first part over here, true, true is a true statement. True, false is a false statement because it's an implication, and it is only false when the starting operation is true and then the ending is false. So true, false is false for an implication. Now, false, true is true, and then false, false is also true for implication. Now we are looking at what? Q implies P, now which is now the reverse. So true, true is a true statement. False, true is a true statement. Now true, false, remember Q comes first, so we are using Q first. So true, false is what? A false statement. Then we have what? False, false, which is also what? A true statement. Now we are going to use the AND operation, or the AND logic operation, on these two to have our final answer. So we have true and true is a true statement. False and true is a false statement. True and false is also a false statement, and then true and true is a true statement. Now remember, the logic operation conjunction or the end is only false, okay? It's only false when one of the true values is false, and it is true when both are true. So we have here true, true, so it means it is a true statement. We have true, true, it is a true statement. But once we have one of them to be false, either here or here, the final answer or the final truth value is false. So this is for the A aspect of this question, which is what? P implies Q and Q implies P. Now let's look at the second aspect of this question. So B. So the B is what? The negation of what? P or Q implies Q and P. So let's go ahead and see the truth table for this. So we have P, we have Q. We can see that we have what? P or Q over here. Then we have the negation of that, negation of what? P or Q. Okay, then we have this, which is what? Q and P. Then we have the final one, which will combine all of them. My table is not up to, so let me create another one here. So the final one is what? The negation of P or Q implying Q and P. So let's go ahead. So we know for any statement P, we have true, true. Sorry, this is true, true, false, false. So for Q, we have true, false, true, false. Okay, so for P or Q, it means either both should be true or one of them should be true to make this column true. Okay, so it means here we have true, true, so it's a true statement for or the disjunction. So we have true, false, it is true because one of them is true. We have false, true, one of them is true, so it is true here. We have false, false, it is false. Okay, so the negation of this statement is what we have over here. Now if we negate true, it becomes false. So we negate this true again, it becomes false. We negate this true, it becomes false. We negate the false, it becomes what? True. So let's go ahead. Now we come to what? Q and P. Q and P. Now let's go. This is our Q and P. So we have what? True, true, true Q, true P is a true statement. Now the Q again, we have false, and then what? This is true. So it is what? A false statement, because both of them has to be true to make the end or the conjunction to be true. Now this is what? True, this is false, so it is a false statement. Now false and false is also a false statement for conjunction. Now we now have the final answer, which, or the final true values, which we are going to write over here between what? The negation of what? P or Q implying what? Q and P. So it means we are looking at these two tables here and here. So this implies this, this implies this. So let's go ahead and see that. So we have false implies true, this is a true statement. False implies false is a true statement. False implies false is a true statement. And then we have true implying false, this is a false statement. I said how come true implying false is a false statement in the previous tutorials. Or for implication, the only way the implication will be false is when the starting material or the hypothesis is true, but then the conclusion is false. So if the hypothesis, which is the one starting, is true, but then the conclusion is false, it becomes what? A false statement. Else the true value for any other condition is true. So let's go ahead. Biconditional. So what is a biconditional? Given two statements P and Q, the conjunction, that is what P implies Q and Q implies P, of implication P implies Q and its converse Q implies P, is called the biconditional of P and Q, and is denoted by the symbol P, the double implication sign Q. So what we mean by the bicondition is if we have a statement or an implication statement that is P implies Q, and we do the conjunction between this statement and its converse will now be what? The reverse of this, which is what? Q implies P. Now this becomes what? The biconditional of the compound statement, or we can just simply say P implies Q and then what? Q also implies P. So this is the biconditional as we are talking about. Now P biconditional Q can also be stated as P if and only if Q, or P is equivalent to Q. Now let's look at the truth table for the biconditional. So we have the statement P, we have the statement Q, and then we have P biconditional Q. So we have the values over here. So we have true, true, false, false, as we normally write for any first statement. And then the second statement, we have Q. Then we have the true values to be what? True, false, just to make it balance. Now for biconditional, if P is true and Q is true, it is a true statement, or both of them has to be the same for the resultant to be what? To be true. If one of them is false, then the resultant will be false. What do I mean by this? Let's look at this. True is what? True, and this true is also this true. So the statement is a true statement. True is false, but false is not true. I take it again. Truth is false, but false is not true. So the biconditional is what? Is false over here. False is not true, and true is not false. So this is also a false statement. Now false is false, and then false is false. So this is true. So now do we see that when we have true is true, it means this true is also this true, this true is also this true. So it is a true statement. We have false is false. False biconditional, false is what? A true statement, because false is false and false is false. Now once one of them is different, it becomes what? A false statement. Alright, so let's move on. Now we need to note something. A compound statement M is called tautology if the true value of M is true for any assigned values of the statement occurring in M. So what do I mean by this? So it means whenever we have tautology as a compound statement, it means the resultant or the truth value for the resultant are all true statements. You will not see any false in there. So let's look at an example. Example number 1. Show that the following compound statements are tautology. We have what? P or negation of P. We have I. Negation of P or Q implies P. So let's go ahead and solve the first one. I, which is what? P or negation of P. So we have P, we have negation of P in the table, then we have the two of them as the compound statement over here. So we have P or negation of P. So for P we have what? True, true. Sorry, this is true, true, false, false. So negation of P will not be what? Negation of true will be false, negation of true is false, negation of false is true, and this is also true. So the operation P or negation of P means one of them has to be true to make the truth table of P or negation of P to be true. So we have true, false over here, and because it is what? Disjunction or the or operation, it is a true statement. So we have true, false is a true statement because one of them is true. We have false, true, and then it is true because one of them is true. We have false, true, and it is true. Now can we see that the truth value for P or negation of P are all true? Yes, because they are all true, we can vividly confirm that P or negation of P is tautology. Alright, now let's see whether the negation of P or Q implies P is also tautology. So the II aspect, which is what? Negation of P implies, negation of P or Q implies P. Alright, so we have our P, our Q statement. We can see negation of P over here, so we should have negation of P. Then we can see what Q implies P here, so we write Q implies P. Then we write the final one between all of them, which is what? The negation of P or Q implies P. So we have P to be true, true, false, false. By now we are used to this. And then our Q statement will be what? True, false, true, false. Now the negation of P will be what? The inverse of this. So true statement will become false, true statement will become false, false statement will become true, false statement will become what? True. Alright, now Q implies P. Q implies P, meaning Q implying this P. So true, true is true. We have false, true is what? True. Now true, false is false. Like I said, when the hypothesis is true and then the conclusion is false, it is a false statement for implication. Alright, so we have the Q again, which is false, false, and then it means this is what? True as well. Alright, so now let's see. We have negation of P or Q implies P. Now we are using the operation what? Or between the two of them. So which means, let me use another color to indicate that we are using the operation what? Or between the two of them, which means if one of them is true, it is enough to make what? The truth table of this side to be true. So we have false here, what? Or true. Because one of them is true, this is true. We have false here, we have true here, so this is what? True, because we are using or the disjunction. Now true, false, this is a true statement, true, true is a true statement. Now can we see that the overall truth value or the truth table for negation of P or Q implies P are all true? Yes, because they are all true, we can also say that what? This is also what? Tautology, as said by the question over here. So assuming you draw the true value for these two, which the question is vividly telling you are all tautology, and you had one of them to be false, it means somewhere in the process of finding the true value you made a mistake. So you need to go back and cross check all your implication or the disjunction or the conjunction to make sure you have just true, all values here to be true for it to be tautology. Alright, let's move on. Contradiction. Okay, so what is a contradiction? Now a compound statement is called contradiction if the true value of M is false for any assignment of the true values of the statement. So it means the contradiction is the opposite of the tautology. So whilst in the case of the tautology where we have all this to be true and all this to be true, for contradiction we are going to have this, all of these values to be false, and then all of these values to be false. Now let's look at an example and see if that is actually what? True. Okay, so example number 1, show that the following compound statements are contradiction. P and negation of P. So we are dealing with the I, which is what? P and negation of P. So I have my P statement, the negation of what? The P, then P and negation of what? P. So my P is what? True, true, false, false. Negation of P will be the inverse of everything over here. So it is what? False, false, true, true. Now because we are using what? The conjunction, which is and, it means both of the operations or both of the statement has to be true for the true value over here to be true. Once one of them is false, it makes it a false statement. So I have true, false. Because one of them is false, it is also a false statement. I have true, false over here, is a false statement. False, true is a false statement. False, true is a false statement. Now can we see that all the true value for P and negation of P are all false? Yes. Because they are all false, we can say what? P and negation of P is a contradiction and not tautology. So this indeed is a contradiction. Now let's look at the second one. So the I have what? P and Q, and Q implying negation of what? P. Alright, so I have P, I have Q, I can see negation of P here, so I have negation of P. I can see what? P and Q over here, so I have P and Q. I can see what? Negation of, Q implying negation of P over here. Then I can see the final overall statement, which is what? P and Q, and what? Q implying negation of what? P. Alright, so let's go ahead and see what we have for this. So I have the P statement to be what? True, true, false, false. I have the Q to be what? True, false, true, false. Now negation of P is the inverse of everything we have over here. So we have what? This will become what? False. This will also become false. This will become what? True. This will also become what? True. So let's go ahead. Now P and Q. P and Q. So we are using this as our first value and then this as our second statement of value. So P and Q. So we have true, true is a true statement. Now we have true, false. Because one of them is false, this is a false statement. False, true. Because one of them is false and we are using what? And or conjunction. This is what? False. So we have false, false is also what? A false statement. Alright. Q implies negation of P. So we are using Q now implying what? The negation of P, what we have over here. So true implies false. Okay? True implying false over here. We are going to get what? A false statement. Like I said, when the hypothesis is true and then the conclusion is false, it is a false statement. Now I have false, false. False, false is what? A true statement for implication. True, true is a true statement for implication. And then what? False, true is what? A true statement. Okay, so we can see that the only way for it to be false is when what? The hypothesis or the one starting the implication sign is true, but then the conclusion or the ending is false. That is when we have a false statement. Now I can see the conjunction between P and Q and then Q and negation of P, which is what we have over here, the conjunction or the end between them. So we can see that we have true, false over here. This is what? A false statement, because we are using what? Let me use another color to indicate that, right? We are using what? The conjunction or the end operation. End operation. So because we are using the end operation, this is what? True, this is false. So because one of them is false, this is false. Let me continue with the same colors. Alright, so we have false, true. This is what? A false statement, because one of them is false. I have false, true is false. I have what? False and true. This is what? False. So we can see that the conjunction between what? P and Q, and then Q implies negation of P, are all false statements. Therefore this statement is also what? A contradiction. Contradiction. Hello and welcome to my science tutorials. In today's video we are going to be looking at logical equivalence. This is the part 4 of the logic tutorial. So what is logical equivalence? Now let's consider two statements R and S. They are said to be what? Logically equivalent if they have the same truth value for all combinations of true value of what? The statement variables occurring in R and X by R triple bond or this triple sign S. Okay, so what do we mean by this? So assuming we have the statement R and then we have another statement what? S. Now after drawing the truth table for R, you find out that the true values are true, false, true and true. And then you did the same thing for the compound statement S. You also found out that the true values are what? True, false, true and true. Now we can see that the truth values of what? The compound statement R and then the compound statement S are all the same. That is, we have true here, false here, then true here, true here, true here, true here. So in this case, we can say what R is what logically equivalent to S because they have the same truth values. Now, if one of them happens to be what, let's make here false. If this becomes false, it means R is not logically equivalent to S any longer because what, one of the truth values among their truth table is what, different. So for logically equivalent compound statements, we have to make sure that what, all their truth values are equal for them to be what, logically equivalent. Now let's have a look at an example to appreciate what we are talking about. So example number 1, show that the following compound statements are logically equivalent. So we have I, P and Q is logically equivalent to what, Q and P. I, we have what, P implies Q is logically equivalent to what, negation of P or Q. Then we have I. P biconditional Q is logically equivalent to what, the negation of P or Q and the negation of Q or P. So let's go ahead and see if actually these two compound statements here and here, here and here, here and here are logically equivalent. So let's go ahead. So so we are looking at what, P and Q to be logically equivalent to what, Q and P. So let's construct the truth table for this particular example. So we have here our P, we have here our Q, then we have what, I can see P and Q here, so I have my what, P and Q. I can see what, Q and P here, so I have what, Q and P. So for the statement P, so I have true, true, false, false. For Q, I have true, false, true, false. Now this is what, P and Q. P and Q, it means what, both of them has to be true for what, the statement over here to also be true. Okay, let's see. So we have here true, true, both are true. So P conjunction Q is what, true. But we have here true, false. Because one is true and one is false, for the conjunction it will be what, a false statement, because we are having what, the conjunction or the end between the two of them. So this is the same, we have false and true, so this is what, a false statement. We have here false, false is also what, a false statement. Now let's look at what the converse of this, which is what, the Q and P. Now Q and P, so we have true here, so we have a true statement. We have false here, we have true here, because this is false, this is also a false statement. We have true here, yes, but here is false, so it's what, a false statement. We have here false and this is false, this is also what, a false statement. Now we can see that what, the truth value for what, P and Q is the same as what, Q and P, because we have true, true, then the rest of them are all what, false. Okay, so because we can see that, we can confidently say what, P and Q and what, Q and P are logically equivalent. Alright, so because we have all the values over here to be the same, we can say what, P and Q is logically equivalent to what, Q and P. Alright, so that is the first example. Now let's look at what, the B, or the second example. So for the B, we have what, P implies Q to be logically equivalent to what, the negation of P or Q. So let's see if these two statements or these two compound statements are also logically equivalent. So we have our P, we have here our Q. I can see negation of P here, so I have negation of P over here. I can see what, P implies Q, so I have what, P implies Q. I can see what, negation of P or Q over here. So let's go ahead and see. So for P, I have true, true, false, false. This, I have what, true, false, true, false. Now the negation of P is what, the inverse of what, the P that I have over here. So true statement, if we negate it, it becomes what, a false statement. So I have here false. True statement, I negate it, it becomes false. I have false statements over here, I negate them, they become what, true. Now P implies Q. Okay, so true implies true, this is a true statement. True implies false, no, this is a false statement. So for implication, like I said, when the hypothesis is true but the conclusion is false, it becomes what? A false statement. Now I have here the hypothesis is false but then the conclusion is true, so this is what? A true statement. I have here false and then this is false, is also what? A true statement for implication. Okay, so negation of P or Q. So I have what? Negation of P or the Q over here. So this is the first one and then this is the second one. So we are saying what? Negation of P or Q. So I have here false true, because one of them is true, this is a true statement. Now I have false false, none of them is true, so this is a false statement. I have here true true, so this is a true statement. I have here true and false, because one of them is true, this is also a true statement. Now we can see that the truth values for what? P implies Q and negation of P or Q are all the same, since we have what? True true, false false, and then true 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 over here. So because the truth values are the same, we can confidently say from the truth table what? P implies Q is truly logically equivalent to what? Negation of P or Q. Let's go ahead and see the C aspect of this question. So the third aspect is what? P biconditional Q is logically equivalent to what? Negation of P or Q and negation of what? Q or P. Okay, so let's construct the truth table over here. So we have what? P, Q. I can see negation of P, negation of Q. So I have negation of P, negation of Q. I see what? P biconditional Q over here. Okay, I can see what? Negation of P or Q. I can see what? Negation of Q or P. Then I can see the conjunction between these two, which is what? Negation of P or Q conjunction what? Negation of Q or P. All right, now remember the logical equivalence is between what? Let me use another color for that. Is between this, the biconditional, this, so it's between this and this. So we'll be comparing the true values over here and over here for us to say whether these two are logically equivalent or not. So I have here the P, we have true true, false false. Q, I have what? True false, true false. Negation of P is the inverse of everything here, so I have here false false, true true. Sorry, this is true. No, you need to be very careful when you are drawing the table, because once you make a single mistake, it makes everything wrong for you. All right, so don't make the mistakes I make during the tutorial. All right, so negation of what? Q means here will become false, so I have false, this is false, so this becomes true. This is true, so this becomes false. This is false, this becomes what? True. Now I have what? P biconditional what? Q. So I have true true, this is a true statement, so let me use the green for that. So this is true, this is true, so we have what? True over here. This is true, this is false. For biconditional, they both have to be the same for it to be true. So because one of them is different, this is a false statement. Now this is the same, one of them is different, so we have false and true, so this is also a false statement. I have here false false, they are both what? False, so it is what? A true statement. Okay, so I have negation of P or Q, negation of P or Q. So this is negation of P, this is Q, so it's between these two, so one of them has to be true to make this to be true. So I have here true false, so it is what? True. I have here false false, so it is what? False. I have here what? True true, it is true. I have here true true, it is what? True over here. All right, I have negation of Q or P, negation of Q or P, that is negation of Q or P, negation of Q here or P. So I have here, this is false for negation of what? Q. This is what? True, because one of them is true, this is a true statement. Now this is what's true, this is also true. It's a true statement for the disjunction or the OR logical operation. Now I have here false. This is also what? False. So it is what? A false statement. Okay, because none of them is true. Now I have for negation of Q, which is this one is true, and then this one is what? The last one here over here is what? False. Because this is true, it makes this also true. Alright, now let's look at what? The conjunction or the end between this and this. Okay, so true and true is what? True for conjunction. False true, this is what? A false statement. This is also what? True and false, because one of them is false. This is a false statement because this is the conjunction or the end between them. We are using what? End between these two. Okay, now this is true, this is true, so this is also true. All right, now can we see that we have here true, false, false, true? Over here we have what? True, false, false, true. Okay, so this and this are all what? They are equal. They are all equal. So we can confidently say what? P biconditional Q is logically equivalent to what? Negation of P or Q and negation of Q or P. Okay, that is from the truth table above over here. All right, let's have a look at one final example to actually deepen our understanding about logical equivalence so that we end this tutorial. All right, so example number 2. Example number 2, show that what? P or into bracket Q and R is logically equivalent to what? P or Q and what? P or R. Okay, this is what we call the distribution law, which we will see in the next tutorial. Okay, so over here we can see that we have what? P, we have Q, we have R. So we have what? 3 different statements. So we have P, we have Q, we have R. So I can see what? Q and R over here. So I'll write that down. So I have what? Q and R. So I have what? P and what? Q. Sorry, P or Q. So I have what? My P or Q. I have what? P or R. Okay, then I have what? P or Q and R, which is for the entire of this. Then I have the entire of this, which is also what? P or Q and what? P or R. Okay, so now that we have our table ready, let's go ahead and input the truth values in there. So for 3 statements, the column that we provide are 8, and then we fill them in this way. So we have true, 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 then we have false, 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 false. So for the Q, we will have true, true, false, false, we have true, true again, we have false, false. Then for the R, which is the last statement, we have what? True, false, true, false, true, false, and then true, false. All right, so now that we are done with that, let's look at what? Let's look at what? Q and R. That is Q and R. Okay, so we have true, true, so this is a true statement over here. Okay, so we have what? True, false, that is a false statement. We have false, true, this is a false statement. We have false, false, this is also what? A false statement. We have true, true is a true statement. True, false is a false statement. False, true is a what? It's a false statement. False, false is also what? A false statement. Now we have what? P or Q. P or Q, that is P or Q. So it means one of them has to be true to make this column what? True. So this is true, 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 true. So this is true. This is true, true. This is also true. This is true, false. One of them is true, so this is true. I have over here true, true. So this is true, false. Sorry, true, false. So this is what's true. This is false. This is true. So it's true. This is false, true. This is true. This is false, false, so it is false here. False, false, it is false, because we are using the operation or what, disjunction. Now let's look at the disjunction between what, P and Q now. So we are having what, the disjunction between P or R. Okay, so this is our P, this is our R, P and R. So we are looking at the disjunction between the two of them, so which means one of them has to be true to make it true. So this is true, this is what, also true over here, this is also true. So we have what, true here. We have here true, false, one of them is true, so this is true. We have here true, we have the R to be true, is also true. We have here true, we have here false, it is true. We have here what, false, we have here true, it is true. We have here false, we have here false, this is a false statement. We have here false, we have here true, is a true statement. We have false here, this is also what, a false statement. Now we have the disjunction or the or between what, P and then the entire of what, Q and R. So we are having between what, this, that is P, and then Q and R, this is Q and R. We are having what, the or the disjunction between them, which means what, one of them has to be true to make this entire column true. So we have here true, this is true, so it is what, true over here. We have here what, true, this is false, it is true because one of them is true. We have here true, we have here false, it is what, true. We have here true, we have here false, so it is true. We have this side to be false, this side to be true, so it is what, true. We have here to be false, and then this side to also be false, so this is the first false statement. We have here false, we have here true, sorry, we have here false, this place also is false, so this is also a false statement. We have here false, we have here false as well, so this is a false statement. Now I'm getting really confused because I'm using the same color, so let me use another color so that I don't get confused. All right, so I have the conjunction between what, P or Q, this, and then what, P or R, this. So we are having what, and or the conjunction, so which is both of them has to be true to make the values over here true. So we have here true, true is what, we have here true, true, so here is true. We have here true, true, this is also true. We have true, true, this is also true. True, true, this is also true. True, true, this is also true. We have true, false, because one of them is false, because one of them is false, that is this one is false, this is what, a false statement. This is false, true, one of them is false, this is a false statement. This is false, false, both of them are false, so it is a false statement. So we can see that we have up to here they are all true, and then coming down they are all false. Okay, so because this is true, this is true, this is true, 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 false, 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 and false, false. Okay, because they are all the same, we can say what, we can vividly now say what, P or what, Q and R is logically equivalent to what, P or Q and what, P or R. So that is how we construct the truth table to show logical equivalence between two compound statements. So thank you so much for watching. I hope you liked the video, and if you do, kindly please press that thumbs up and then subscribe to our channel, because we provide daily videos on biology, chemistry, mathematics, and physics. Subscribe and press that notification button to get notified when we upload new videos. So thank you once again, and I'll see you in the next video. Bye bye.